students, I welcome you to my class on Introduction to Embedded Systems. In the previous lecture, we have come across the overview of the subject, its content and certain application area, and we get some brief idea about the embedded system. So in today's class, we will be able to explore it further. We are starting our discussion on module 1. So in the day-to-day life, we come across a wide variety of consumer electronics products. Some common examples are TV remote controllers, mobile phones, vending machine which we use for uh, dispensing a cup of tea or coffee as per the user's need, Xerox machine, printer, etc. Each of these devices does have one or more programmable device waiting to interact with the environment as effectively as possible. These are a class of embedded systems and they provide service in real time. That is, we need not have to wait long for the action. The moment we give the instruction, they will take action and show us the result. An embedded system may be defined as a device that includes a computer, but it is not itself a general purpose computer. So embedded system is basically a computer, we can say like that, but its look will vary from application to application. Unlike general purpose computer like our laptop, desktop, they have a particular shape, and whenever we talk about a general purpose computer, we develop an image about that a particular type of object where there is a screen, there is a keyboard. But unlike that, in an embedded system, uh, mm, based on the application, their shape, size, form factor, etc. varies from product to product. Consider the case of a mobile phone, which is a very complex device. The mobile phone, which you call smart phone also, it houses a number of miniature gadgets like digital camera, audio and video player, LED display, FM radio, etc. functioning coherently on a single device. This device has number of operating modes like we may like to adjust the zoom of the digital camera, so this can be the camera working in different modes. We may like to reduce the screen brightness, so accordingly we can adjust that. We may like to change the ringtone. We may like to use it as a calculator, as a gaming device, email device, and so on and so forth. So these variations in the functionality can only be achieved by a very flexible device. This flexible device sitting at the heart of the circuit is none other than a customized microprocessor, better known as an embedded processor, and the mobile phone housing a number of functionalities is known as an embedded system. So far we have come across different type of definitions of embedded systems. The mobile phone is an example of a real-time embedded system, which is in short called RTES, as it satisfies the requirement of a number of users at the same time. Means it performs real time operation, like between when you make call, it may be doing real time operation between you and your friend. And when you are listening to a radio station broadcasted program, so the real time is between the listener, that is you, and the radio station. And when you make call, it interacts in real time with the telephone network, and so on. And obviously there will be a small delay involved, and that delay is often acceptable. A real-time embedded system is precisely the union of subsystem to discharge a specific task coherently. A system is a real-time embedded system when it supports the execution of applications with time constraints on that execution. So the time constraint within which the time deadline or time frame within which the job is to be completed are defined, and the embedded system is capable to execute within the defined time frame. So that's why they are called real-time embedded system. So RTES can further be classified as hard and soft real-time system. So this real-time operating system is basically divided into two fundamental categories. One is called hard real-time and another is called real-time. Now if we explore them further, in hard real-time system, no lateness is accepted under any circumstances. For example, a control system of an aircraft, airbag deployment system in cars or pacemakers, which are very stringent about the time. If the time is over and it is not able to perform the desired action, then their catastrophic effects takes place. So these are examples of hard real-time system. On the other hand, in the soft real-time system, they can allow some delay, but at some cost, obviously. For example, a slow vending machine can serve lesser number of customers. So if the inputs are given and it takes certain uh, time and there is a delay incurred, so as a result what will happen, the number of customers served within that period may be lesser. So other examples are video streaming, where there can be some buffering, digital TV set-top boxes, so there also can be some sort of late actions or delay can be there, which may be acceptable. Audio playback systems, where also delay can be will not be having any catastrophic effect, which can be sustained. So an embedded system is a special purpose system in which the computer is completely encapsulated by the device it controls. So the computer takes the shape of the appliance itself. Unlike a general purpose computer, such as a personal computer, an embedded system performs predefined tasks, usually with very specific requirement. Since the system is dedicated to a specific task, design engineers can optimize it, reduce the size and cost of the product. Embedded systems are often mass produced, so the cost savings may be multiplied by millions of items. So these basically try to focus that since they are their work is application oriented, specific application oriented, so whatever best performance is required for that application and related to whatever resources are required to fulfill that, only these components, these resources are kept part of the embedded system. So that way optimization can be done, and the unnecessary components, unnecessary resources can be discarded, and that will give a very cost advantage compared to the general purpose uh, computers. So this slide shows a general architecture of a hypothetical real-time embedded system where a microprocessor with RTOS. So